requirement of this back titration. So these are the criteria, like insoluble substance है जैसे कि barium sulfate है, then this all calcium C2O4 twice PbSO4, then this magnesium phosphate. These are usually soluble in hot EDTA, right? So the reaction between this metal and EDTA is slow and incomplete. So like example क्या है, इसके लिए आयरन है, एल्यूमिनियम है, क्रोमियम है, थोरियम है, right? And if suppose your metal ion is precipitated at the pH suitable for titration, like है this aluminum hydroxide, right? So the color change at the end point for this back titration is from free indicator color to the metal indicator complex, है ना? Free indicator जो color होगा अब यहाँ से उल्टा हो जाएगा. When metal will form a complex with that indicator, that will be your color change. So this is completely opposite that the direct titration, right? Now here the one example is given for determination of aluminium salts. So the sample of aluminum is heated with known excess of standard EDTA at pH 7 to 8. Okay. Now this solution is adjusted to pH 10 using ammonia buffer. Okay. And the residual EDTA is titrated against. हमारा sample ये है. ठीक है, एक्सेस हमने ये EDTA डाला है. You have maintained your pH 10 with this ammonia buffer, and now the residual EDTA is titrated against. आप कौन से कर रहे हो? Standard solution क्या है? Zinc का, using heliochrome black tea indicator. So the color change from blue to wine red. Generally क्या होता है? Direct titration के अंदर wine red to blue होता है, but in back titration this will be reversed. So you can see this is aluminum, here is your indicator. So this will, you can see the aluminum will form the first complex with the indicator, right? Now what will happen? Then zinc comes from the burate. So what will happen? They will again see this particular condition. Now what will happen? HPH 10, this will again form a complex, and here you can see this Zn and this hydrogen, and this again hydrogen indicator, and then this will be Zn will form a reaction with this indicator. Okay, so here see, as Zn is complexed with this indicator, so initially your indicator was blue color, but when it will be again with the metal ion, so that will be in wine red. Whenever indicator will form complex with the metal ion, so that is having what? Wine red color. Okay. Next is replacement titration. So when both back titration, what is the requirement for this replacement titration? So of course there are certain limitations are associated with the back titration and direct titration. Okay, so with this both titration, it's not possible due to the endpoint not being sharp enough, है ना? So then the replacement titration is a method of choice. Okay, अगर आपको sharp endpoint you cannot get with these two types of titration, then you can go for this replacement titration. So in this method of titration, determination of metal ion is done by displacing magnesium or zinc ions from EDTA complex with an equivalent amount of metal ion, and liberated magnesium or zinc ions are then titrated with the standard EDTA solution. So here as indicator you can use mordant black. So see, this is one example. Calcium salt is determined in this way, like a standard volume of magnesium EDTA solution to calcium salt is in the presence of buffer. So what will happen? Calcium displace magnesium ion and form a stable complex, because stability of calcium EDTA is more, right? So with EDTA, as Ca EDTA complex is more stable, the displaced and liberated magnesium ions are then titrated with standard EDTA solution using mordant black as the indicator. So cadmium, lead, mercury can also be determined by using this replacement titration. Now the alkalimetric titration of metal ions. So metal EDTA complex formation reaction explains that protons are liberated from the disodium EDTA, leading to the formation of acid. So you can see in this reaction the acid that is formed can be titrated against the standard alkali, but in an unbuffered solution, right? So endpoint detection can be done by using acid-base visual indicator or potentiometric method of detecting endpoint, right? So this is what alkali metric titration. This is not most widely used titration because you can simply perform the acid-base titration instead of this alkylimetric titration method. Okay. Now masking and demasking. है ना? Here, when there are so many metal ions are present in your sample solution, so of course you have to mask or demask that particular metal ions, right? So masking agents. So these are the reagents which prevent interfering ions from reaction without physical separation. उसको क्या करो इस तरीके से फिजिकली हमको निकालना नहीं है बट यू कैन ऐड सम रीएजेंट वो क्या करेगा एक साइड पे बैठा रहेगा दैट विल नॉट इंटरफियर ड्यूरिंग योर टाइट्रेशन so these reagents form complexes with interfering ions which are more stable than complexes formed with the indicator and EDTA वो उससे भी ज्यादा powerful होता है right so examples है like here you can see KCN. So this is mainly used, this potassium cyanide mainly used for the masking agents for the silver, copper, cadmium, cobalt, nickel, zinc, etc. Right. Then second one is the triethanolamine. Okay, so this is used for the masking of iron, aluminium, tin, and then fluoride. So this is useful for again iron and aluminium to give hexafluorocomplex, right? And then iodide. So this is used for the masking this Hg2 plus mercury to give tetraiodo complex. Now another agent that is your demasking agent. So this is the process in which masking substance reverts back to its ability to take part in the reaction. Okay, so these reagents which again the ability of masked ion to enter the reaction with indicator and EDTA. For example, masking by CN can be removed by mixture of formaldehyde and acetic acid. Okay, so in addition of this demasking agent to this particular complex, what will happen? Zinc will be liberated and again it will be titrated. Right, so this is the less stable and this one is the more stable. Okay, now I'll show some videos so you will have some better idea. Okay, before this, I'll show journal content. Yes, so this is simultaneous determination. Is my screen visible?
Yes, ma'am.
Okay, so you can see this first practical that is the simultaneous determination of iron and chromium by EDTA titration. Okay, so the principle, what is the principle, basic principle of this titration? So this is here, this is based on the kinetic masking. Okay, so what happened in this kinetic masking? You can see the iron 3 reacts with the EDTA at normal temperature, while chromium doesn't. So this is a special case in which a metal ion does not effectively participate into the complexation reaction because of its kinetic inertness. So the slow reaction of chromium with EDTA makes it possible to titrate other metal ions which react rapidly. है ना लाइक अभी सैंपल के अंदर क्रोमियम है आयन है अदर मेटल आयन है अब क्रोमियम क्या बोलता है कि मैं इतना इनर्ट हूं ना कि अगर मुझे टाइट्रेशन में पार्ट लेना है तो आई नीड सम सर्टेन टेम्परेचर मुझे टेम्परेचर चाहिए 50-60 डिग्री जितना दे दो देन आई विल टाइट्रेट तो जब तक क्रोमियम रहता है उसके साथ में दूसरे मेटल आयन रहते हैं तो यू कैन इजीली डिटरमाइन है ना क्योंकि वो एक साइड में ही रहता है क्योंकि उसकी एक इनर्टनेस है और जो Fe है वो क्या बोलता है कि मुझे तो नॉर्मल रूम टेम्परेचर पे आई कैन इजीली टाइट्रेट विद द EDTA है ना सो यू कैन सी हियर yes these are the required solutions for iron chromium EDTA then this is lead this is HNO3 and this is xylenol orange indicator and here is the hexamine powder so procedure for this in first of all, you will do blank titration, right? So here what will happen? You will take 10 ml of distilled water in a conical flask. Then you will add 20 ml of EDTA and then sufficient amount of hexamine to maintain pH 6 and add 3-4 drops of xylitol orange indicator. And you have to titrate it with against what? 0.01 molar lead nitrate solution. What till what color change from yellow to red. So this will be your blank reading. Okay, you have simply taken here only distilled water, no sample solution, right? Now in the second part there is a titration of Fe. So here you will take 10 ml of your sample, 10 ml of distilled water you will add in a conical flask. Further, what you will add 20 ml of this 0.01 molar EDTA, then hexamine powder and 3-4 drops of xylitol orange indicator. So, and you will titrate it against 0.01 molar lead nitrate. So, okay, this is another kinetic masking is there. So, what is the other name of this titration? ये कौन सा टाइप का भी टाइट्रेशन हुआ? सोच के बताओ. इसमें क्या किया है? EDTA को कोनिकल फ्लास्क के अंदर ऐड किया है. एंड नाउ एक्सेस ऑफ EDTA यू आर टाइट्रेटिंग विद द मेटल सॉल्ट. तो ये कौन सी टाइप का टाइट्रेशन हुआ? डायरेक्ट टाइट्रेशन, बैक टाइट्रेशन, रिप्लेसमेंट टाइट्रेशन और अल्कलीमेट्रिक टाइट्रेशन. टेल मी. What? Back titration. What? Pardon? बैक टाइट्रेशन हुआ ना, क्योंकि ईडीटी तुम डाल रहे हो और सामने मेटल के सामने उसको डिटरमाइन कर रहे हो एक्सेस ऑफ ईडीटी को, राइट? सो हियर अगेन द कलर चेंज विल बी येलो टू रेड. नाउ इन पार्ट सी again you will take 10 ml of your sample, 10 ml distilled water, but here in acidic condition, that is 1 ml 2 ml jitna 1 molar HNO3 you will add and boil the solution for 15 minutes. Okay, and after that once you have boiled the solution and it will be at particular temperature, then you will add the 20 ml of, okay, sorry, before boiling you have to add the EDTA, right? And then you will add hexamine to maintain pH and then 3-4 drops of indicator solution, and then again color change will be yellow to red. So now the observation. So here blank you have taken. So how you will minus blank minus X. So that will be V1, okay, for iron, and for chromium, why this B minus Y minus B minus X is equals to X minus Y. ये ऐसे क्यों किया है? Because chromium, when you hit the solution, chromium will be participant, but that doesn't mean कि Fe participate नहीं करेगा. ठीक है, तो अगर आपको क्रोमियम की रीडिंग निकालनी है, so you have to do what? X minus Y. Okay, so at that time you will get the reading for chromium. Okay, and these are the calculation for the titration, and your answer will be in milligram, right? Now second is just like मैंने आपको ऐसे समझाया आपको हार्डनेस ऑफ वाटर सैंपल के अंदर इन डिटर्मिनेशन ऑफ कैल्शियम एंड मैग्नीशियम, सेम फॉर दिस कैल्शियम एंड जिंक. Okay, so in calcium and zinc, these are the requirement. Zinc, mostly we use zinc nitrate and calcium nitrate salts and pH 10 buffer. Yes, this is the preparation for how you will prepare pH 10 buffer. So when you have to prepare this 1 liter solution, you have to use the 159 gram of ammonium chloride and 586 ml of ammonia, liquor ammonia, and then you have to make up it with the water till what 1000 ml solution is formed. So again this is the same as the above procedure, like 10 ml हमें mixture लेना है, distilled water you will add, 10 ml buffer you will add, and 3-4 drops of idiochrome black tea indicator, and that you will titrate it against 0.01 mole in EDTA, right? So, and for you have to perform one exclusive part for particular metal ion. Like here, you will do it for zinc. Okay, so for zinc, you have to change some condition. You have to use the water. Sorry, you have to use hexamine. Okay, so here once you add hexamine, so what will happen? ये जिंक ही क्यों इसमें टाइट्रेट होगा? क्योंकि कैल्शियम क्या हो जाएगा? दैट विल फॉर्म कैल्शियम हाइड्रोक्साइड एंड दैट विल नॉट पार्टिसिपेट इन द टाइट्रेशन एंड लिविंग ओनली जिंक. So zinc will titrate in the presence of this hexamine, that is pH 6. With the use of hexamine, you have maintained the pH 6 and xylenol orange you have used as the indicator. Okay. So this is what for just a minute. Yes. I will show some calculation. Yes. This is for zinc and calcium and your answer in milligram. Right? Same for the same thing for lead and magnesium. The procedure will again remain same. Here you are doing the lead. So what will be the precipitation here? Form magnesium hydroxide. Right? So that will not participate in the titration at pH 6. Okay. Now I will show some video so you will have some idea about. Yes, here this is. Just a minute. आप लोगों को कोई क्वेश्चन है? Meanwhile you can ask me. Okay. First I will say this aloud. Okay, I'm sharing my screen again here.
The title of the experiment is Determination of Chromium 3 and Iron 3 in a mixture by kinetic masking method. Harshendra K. and Dr. H. Hassan. Kinetic masking is a special case in which a metal ion does not effectively enter into the complexation reaction because of its kinetic inertness. Thus, the slow reaction of chromium 3 with EDTA makes it possible to titrate other metal ions which react rapidly, such as iron 3, without interference from chromium 3. So, which is illustrated by the determination of iron 3 and chromium 3 in a mixture by kinetic masking method. Reagents required for this experiment are indicators.
Let's see from this. Yes.
This experiment consists of 3 steps. Step 1 is standardization of EDTA solution. Step 2 is estimation of iron. Step 3 is estimation of chromium. For the standardization of EDTA solution,
is this video audible to you all?
Yes, ma'am.
Yes, ma'am. Okay.
Take the EDTA solution in the burette and pipette out 10 ml of the zinc sulfate solution in a conical flask. To that, add 3 ml of buffer solution of pH 10.
Okay, one part that is remaining, that was remaining to explain. Yes, as we repeatedly use EDTA as your titrant, right? So you have to standardize it. When you use HCl and NOH, so mainly you use KHP, that is potassium hydrogen thiolate, as a primary standard, right? So for EDTA standardization, you can use salt solution, standard salt solution like zinc sulfate, zinc nitrate, magnesium sulfate. Okay, if your solution of EDTA is 0.01 molar, okay, then prepare the same standard solution of metal ion of same concentration 0.01 molar. Okay, and you can titrate with this against what EDTA using the same condition like pH 10 buffer you will add xylitol orange, sorry, areochrome black tea indicator you will add. Okay, and then by doing N1 V1 N2 V2 you will get the molarity of your EDTA solution. Okay, so this is the standardization part. So here in video you can see how they are standardizing the EDTA solution. They have used zinc sulfate as the primary standard. Okay.
And areochrome black tea indicator. Shake the solution and titrate it against the EDTA solution till the color changes from wine red to blue. Note down the burette reading and repeat the experiment until you get the concordant values. From burette readings, molarity of EDTA was calculated by substituting molarity of zinc sulfate, volume of zinc sulfate, and volume of EDTA.
Okay. Yep.
For
Sorry.
the estimation of iron,
तो ये कैसे किया है like
Dr. Harshendra K and Dr. As take the standard A.
So here the same equation M1 V1 M2 V2 as you have to find the molarity of EDTA. So here you will write ZnSO4 that you have prepared what 0.01 molar and you have taken 10 ml for the titration and you get the burette reading what 10.1. So here you can see the molarity. So this is very accurate solution that is near to 0.01 molar, right? Next.
For the estimation of iron, take the standard lead nitrate solution in the burette and pipette out 10 ml of the metal mixture in a conical flask. Place it on a magnetic stirrer. Dilute this solution with 20 ml of water and to this add 20 ml of EDTA solution. Add hexamine to maintain the pH of the solution between 5 to 6. Add few drops of xylitol orange indicator and titrate this solution against standard lead nitrate solution till the color changes from orange to violet red. Note down the burette reading and repeat the experiment till you get the concordant values. Do not discard this solution as we'll be using the same solution for the next step. From burette readings, volume of EDTA was calculated by multiplying molarity of lead nitrate with volume of lead nitrate and dividing it by molarity of EDTA. The volume of EDTA consumed is equal to 20 minus 9.19, which is the volume of EDTA calculated, will give the value of 10.81 ml. Molarity of iron in the mixture is calculated by multiplying the molarity of EDTA with volume of EDTA and dividing the obtained value with volume of metal mixture. Similarly, amount of iron in liter of the mixture solution is calculated by multiplying the molarity of iron with molecular weight of iron. To the previously titrated solution, 20 ml of EDTA solution was added and few drops of 1 molar nitric acid was added to maintain the pH between 1 to 2. The solution was boiled for 15 minutes until it is reduced to half. After boiling, it was cooled and diluted to 100 ml with distilled water, and to this, hexamine was added to maintain the pH between 5 to 6. Few drops of xylanol orange indicator was added, and the resulting solution was titrated against standard lead nitrate taken in the burette till the color changes from orange to violet. The burette readings were noted down and the experiment was repeated to get the concordant values. From the burette readings, volume of EDTA was calculated by multiplying molarity of lead nitrate with volume of lead nitrate and dividing it with molarity of EDTA. Further, volume of the EDTA consumed is equal to 20 minus 10.6, which is the calculated volume of EDTA, which gives the value of 9.4 ml. Molarity of chromium in the mixture was calculated by multiplying molarity of EDTA with volume of EDTA and dividing the value with volume of metal mixture. The amount of chromium in liter of the mixture solution was calculated by multiplying the molarity of chromium with molecular weight of chromium.
Silence. Please wait for your turn. Okay. Uh, any questions now? This session is now open for your question if you have any. If not, then you will prepare MCQs. I'll share the link for the presentation and also share the journal for these practicals. And I think you all have Vogel for quantitative analysis. आपके पास सबके पास है Vogel. उसमें कॉम्प्लेक्सोमेट्रिक टाइट्रेशन बहुत अच्छे से एक्सप्लेन किया है. So you can read that one. So you have to prepare MCQs from this 3 practicals. आज हमने 3 practical देखे हैं, zinc, calcium, lead, magnesium and iron, chromium, right? Zinc, calcium and lead, magnesium, this both are direct titrations, while this one is the kinetic masking. Iron, chromium क्या है? Kinetic masking. और क्या हो गया? Back titration, right? Okay. So कौन बनाएगा? बताओ. Who will prepare MCQ? आप जो पूछोगे वही प्रैक्टिकल एग्जाम में आएगा. I'll correct जो भी आप बनाते हो. And next time we'll see 3 TLC practicals. Okay. आप लोगों को please, if you have any question, please feel free to ask me. Urmi.
Yes, ma'am.
आज कोई क्वेश्चन नहीं है तुम्हें?
No, ma'am.
सब समझ में आ गया? ठीक है, तो फिर मैं ही आपको क्वेश्चन पूछती हूँ. पूछूं?
Yes, ma'am.
Okay. What is the requirement of back titration? Who will answer? What is the requirement of back titration?